The last session was seen the what meant by the full pitch winding and the short pitch winding. And today's session will derive the equation for coil span factor and distribution factor. We know that the angle between the adjacent poles is 180-degree electrical. If the coil sides are placed 180-degree electrical apart, then if they are connected, then becomes full pitch coil, and is called as a full pitch coil, in which the coil span is 180 degree. Then it is called as a full pitch winding. In other hand, once again the pole pitch is 180 degree electrical. However, the coil spans are placed in such a way that the span is less than 180 degree. In that case, it is shorted by an angle of alpha. Then the coil span is 180 minus alpha. Then such type of winding is called as a short pitch winding. That is, the coil span is defined as it is the angle between the adjacent N and S pole. That is a coil side which is placed between the two different poles with a coil span of 180, then it is called as a coil full pitch coil. Or if it is placed less than 180 degree, then it is called as the short pitch winding. The terminology used here are: the topi is the pole pitch, it is always the 180 degree electrical. However, the coil pitch is depending upon where exactly two coils are placed, whether it is placed apart 180 degree or less than 180 degree. If they are placed tau c is 180 degree, then it is called as full pitch. The tau c is less than 180 degree, then it is called as a short pitch winding. Then these are the terminologies were used in the alternator, whatever derive the equation for full pitch winding and the short pitch winding in the form of the coil span factor. The another factor is the distribution factor. The S is the total number of the slots in the armature of the alternator. P is the number of poles in the alternator, and this S number of slots are distributed for P number of poles. That what you are calling is the number of slots per pole. Then you are getting that is S divided by P. S divided by P is the number of slots per pole. That is also is equal to the pole pitch. That is, so many slots constitute the pole pitch, that is equal to 180 degree electrical. Then the number of slots per pole once again redistribute for three different phases, because it is a three-phase winding transformer alternator. Then this n number of slots per pole is distributing among the three phases R, Y, B. Therefore, the number of slots per pole per phase can be obtained by S divided by P into the number of the phases. That is P into number of phases. In this case, the number of phases is 3. Then we were interested in the angle between the adjacent poles. That is what we are calling as the beta. The beta is the angle between the two successive slots. The angle between the two successive slots, or it is the angle between the two slots. We know that for the number of slots per pole is also is equal to 180 degree. Then we know that what are the number of slots per pole based on the number of slots and the number of poles. Then the angle beta is nothing but 180 divided by the number of slots per pole, because for n number of slots per pole we have got 180 degree. For the one slot, the angle is 180 divided by n. This is how we have to find out the angle between the adjacent slot. Then I told you this is a pole pitch. The pole pitch is nothing but S by P. Also, it is equal to 180 degree. That is, the number of slots per pole is equal to 180 degree. Then the coil pitch as the represented by tau c. If both coil pitch and the pole pitch are equal, then it is called as a full pitch. If it is less than, that is the coil pitch is less than 180, then it is called as short pitch winding. The alpha is short pitch angle. The angle alpha is short pitch angle. That how we are getting is, it is a tau p minus tau c, so that we are getting the alpha. That is tau p is 180 minus tau c, that is a coil, actual coil span factor. In that case, we are getting the alpha. Okay. With this, the terminology is just we want to define the what do you mean by coil span factor. The coil span factor or a pitch factor, which is defined as, it is a ratio of the EMF generated in a short pitch coil to the EMF generated in full pitch coil. That is, you are defining the pitch factor in such a manner that it is a ratio of generated voltage in the full pitch, short pitch winding to the full pitch winding. You are taking a ratio. That is, the Kc is equal to coil span factor, that is equal to EMF generated in the short pitch coil to EMF generated in the full pitch coil. This is how we are defining the coil span factor. Then to find out actual value of the Kc, then we have to find out the EMF generated in short pitch coil, and also you have to find out what is the EMF generated in full pitch coil. First we will take up the full pitch coil, in which the induced voltage in each coil side is ECS. That is, it is a voltage induced in each coil side. There are two coil sides in one coil, two coil sides in the coil side. Then the sum of the voltage of the two coil side is what we are calling is the resultant coil voltage, that is given by ECR. It is represented by ECR. Then first I will consider full pitch winding. We know that the two coil sides are displaced 180-degree electrical. Therefore, the induced voltage in the two coil side is displaced by 180 degree. Therefore, to this ECS, that is a voltage induced in the one coil side, is added to the voltage induced in the other coil side in such a manner that the phase displacement is 180 degree. Therefore, the ECS is added here. That is, it is a full pitch coil. Therefore, phase displacement between the two coil side is 180 degree. Therefore, what I am getting is the total resultant, the voltage, that is coil voltage. ECR is a coil voltage. From this figure, it is quite evident that for a full pitch winding, the resultant voltage, that is ECR, is equal to what I am getting is 2 times ECS. I am getting 2 times ECS. Then we look for what is the EMF generated in the short pitch coil. Here, in the short pitch coil, the coil span is less than 180 degree. It is less than 180 degree. For example, I am taking here, that is, it is shortened by an angle of alpha degree. Short pitch by an angle of alpha degree means the coil span is 180 minus alpha. Therefore, you have to add the coil voltage, coil side voltage to this factor in such a way that the phase displacement between the two coil side voltages 180 minus the alpha. That is, it is shortened by alpha, or the coil span here is 180. The coil span is 180 degree here. That is, here in the case of here it is 180 because coil span is 180 in the full pitch. In the short pitch it is 180 minus alpha. Therefore, this ECS is added to the first ECS by an angle of 180 minus the alpha. If you look into this, what I am interested is the resultant voltage ECR, the resultant voltage ECR, that is, you have to find out the resultant voltage ECR. Now, it is in this particular triangle, if you are considering this particular triangle, In this particular angle ECS, it is also ECS, means it is has got two equal sides. Therefore, the angle opposite to the equal sides are equal. That is this angle and this angle, because opposite to this side, this is the angle, opposite to this is this angle. Here, because we know that for this particular triangle, the total angle is 180. Out of that, you have got 180 minus alpha. Means the sum of these angles are equal to the alpha. Because it is total, you have to add 180 minus alpha plus x plus y if we are taking is equal to 180. Therefore, alpha is equal to what I am getting is the value of x plus y is equal to alpha I am getting. The alpha is the limit. It is half of this and half of that. Therefore, you are getting alpha by 2 and alpha by 2. Then it is shortened the angle, that is alpha, because it is 180, means if you are taking this is 180, therefore this angle should be alpha. Then for finding out ECSR, what I am doing here is I am completing the right angle triangle. That is what I am doing here is this right angle triangle. Here I have what ECS cos alpha. I am resolving this into its x component and y component here. That is in terms of if you are considering this particular triangle. If you are considering this triangle, then I am finding out this ECS resolving along the x and y axis. What I am getting is ECS cos alpha and ECS sin alpha. Then to apply the Pythagoras theorem for this particular right angle triangle here, that is ECR is equal to under square root ECS plus ECS cos alpha whole square plus ECS sin alpha whole square. That same thing I am writing here. That is ECR is equal to under square root ECR plus ECS plus ECS cos alpha, ECS plus ECS cos alpha whole square, that is x square, and y square is ECS sin alpha square, ECS sin alpha square. Then you have to square it, simplify it, and what we are getting is 2 times ECS cos alpha by 2. For full pitch winding, the resultant voltage I am getting 2 times ECS, whereas the short pitch winding I am getting the resultant voltage is ECS cos alpha by 2. Then if you are taking the ratio of these two voltages, that is EMF generated in the short pitch coil, that is 2 ECS cos alpha by 2, and EMF generated in the full pitch coil, that is 2 times ECS, then what I am getting is cos alpha by 2. Then that is ultimately the coil span factor, the Kc is equal to cos alpha by 2. Then if you are observing the generated voltage, you are getting a short pitch winding has got lesser voltage as compared to the full pitch winding. Even though we are getting a lesser voltage in the short pitch winding, we are using the short pitch winding in the alternator so that it is reducing the harmonic, so that we are getting a pure sinusoidal waveform of the output voltage. That is why they are going on a short pitch winding or short pitch winding rather than the full pitch winding. That is the importance of the short pitch, because it reducing the harmonics content in the EMF. Okay, on this we will solve one numerical, that is calculate the pitch factor for the under given condition. There are 3 conditions. For 3 different conditions you have to find out what is the value of the Kc. First case, 36 stator slots, 4 poles, short pitch angle is 40 degree. In A is very simple. We are not bothered about the 36 slots and the 4 poles because our Kc is cos alpha by 2. What I want is the alpha, but alpha is already given here. The already given is the 40 here. Therefore, alpha is equal to 40. Therefore, Kc is equal to cos 40 by 2. Therefore, cos 20, that is 0.94. Second one is 72 stator slots, 6 poles, and coil span is 1 to 10. Then here he is not given a coil span in terms of angle, but he is given in terms of the number of the slots, that is between the 1 and 10 there is a coil span. The coil side is one coil side is placed in the slot number 1, the another is placed in the 10th place. If we are looking into the angle between the two spots, that is between 1 and 10, and we are getting around 135 degree. And how exactly we are getting 120, that we are seeing now. See here, the number of slots per pole, the number of slots per pole, number of slots per pole is nothing but your n is equal to 72 divided by 4, that is add as 72 divided by 6, the number of the poles are 6. We are considering here the B, here it is a B, therefore that is 6 ones are 6, that is n is 12 slots, means that there are 12 number of slots per pole. Therefore the angle between slots, we are getting 180 divided by n, that is equal to 180 divided by 12, that is what we are getting is 15 degree. The angle between the two slots is 15 degree. In this case, the number of slots, if it is a full pitch winding, there are 12 slots between the two in one pole pitch, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 slots. That is, the coil are placed, one is at coil number, that is in the slot number 1, the second one is placed, that is this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is another is placed here. The another coil side is placed here. If you are connecting these two, it has become a 1, 5. Here, what is the angle here? There is a 50, 30, 45, 60, 75, 90, 105, 125 and 135. The span what we are getting is 135. Therefore, alpha is equal to 180 minus 135. That is what we are getting is 45. This is how you have to calculate the angle here. Then you can substitute the same thing. That is, we are getting 45, you can put it, then we are getting 0.924. In second case, he is given coil span itself is 150, therefore alpha is equal to 180 minus 150, that is what we are getting 30, can straight away substitute, then you are getting the Kc value is 0.965. This is how you have to solve the numericals on the coil span fact.